Welcome to another podcast. In this episode, we're going to be taking a look at some basic operations involving percentages, primarily aimed at looking at the percent increases or decreases through expressing a percentage as a multiplier. So I want to start out with just a basic example to illustrate this, and I'm going to take an arbitrary quantity x, and I'm going to write down expressions for each of these different percentage changes in the value x. Just to give you a feel for this. So for example, suppose I said that the quantity x increases by 8%. I think most of you are used to saying you take x plus 8% of x and add it to it. The result of doing that is if you factor out the x, you get 1 plus 0.08x, which is equal to 1.08x. And so what I want you to get out of this example is that if we want to increase something by 8%, then we multiply by a number that is greater than 1 by 8%. So the multiplier 1.08 increases the number by 8%. If you're multiplying a number by bigger than 1, then you're increasing it. If you're multiplying a number smaller than 1, then you are decreasing it. Now, for the purposes of this, we're not going to be multiplying by any negatives. So we don't have negative percentages. Instead, what we have is either plus 1 or plus a percentage larger than 1 or minus a percentage less than 1. What I mean by that is looking here at decreases. If I just kind of pick up with where we left off with the last problem, then since I'm decreasing, I'm subtracting from 1 5% times x, and that leads to a multiplier of 0.95. This is like saying if you decrease an item by 5%, then you're only looking at 95% of that item left. If I increase something by 100%, then I'm adding 1, which represents 100, to x. That's the same thing as 2x, which means that increasing by 100% is the same thing as doubling. So here is a interesting problem for this last one. Suppose I decrease something by 10%, then again decrease by another 10%. The question is this the same as decreasing by 20%? And so I want to give you sort of a small example of this. Example would be, suppose I had $100 and I decrease it by 10%. So I subtract 10%. Well, we know from the examples above that that is taking 0.9 of the 100. That's how you decrease by 10%, which would leave me with $90. If I do that again, then I now have $90. And if I decrease that by another 10%, then that is 0.9 of 90 now. And so the decrease isn't as much. If you take 0.9 times 90, you end up with $81. And so if you look at what the overall change is, then we changed from $100 to $81. So this is the original price. And this is the new price. So there's a formula that tells me if I want to figure out the one-time change there, the formula for that is something called the percent change. And so this is the percent change formula. It is equal to the new value minus the original value divided by the original value, and then you can convert it to a percentage from there. So for this example, if I want to calculate the percent change for this problem, it would be the new value of 81 minus the original value of 100 divided by 100 would be negative 19/100ths, or negative 19%. So if I divide those two by each other, I get negative 0.19, which is the same as negative 19%. So the point is, percentages are not additive. And maybe if you get nothing else out of this video, I want you to walk away with that. What I mean by percentages are not additive is, here for this problem we lost 10% twice. So I can't simply take minus 10% and say that that is equal to minus 20%, because it's not. You see that those are two different values for this problem. And so, however you want to do this, this is not the way to handle this problem. We do not do that. We do not add percentages. Percentages are not additive quantities when you're trying to determine an overall rate. So instead, percentages are multiplicative when determining rates. So if I was to redo this problem, if you have a quantity x that that decreases by 90%, decreases by 10%, and then it decreases by 10% again, then you would take 0.9 of the 0.9x, which you multiply those, you do not add them, and that gives you 0.81x. And so 0.81x represents a 19% decrease. So that's the multiplier method of determining sort of overall percent change of these multiplicative rates. It gives me the exact same thing as the percent change formula up here gives me, without having to resort to any specific value. I just used x as sort of this unknown quantity. And if I wanted to use the percent change value here, then I could just look at, okay, my new value is 0.81x. My old value, well, I started with x over x, and you see that what you end up with here is negative 0.19 x over x, which is negative 0.19, or minus 19%. So regardless of how you want to do this, whether you want to use the multiplier method like I did here, or whether you want to pick a specific value like I did here, I just pulled 100 out of the air and went ahead and did the problem, you're going to end up with the same answer. It doesn't matter the amount of money you start with, the overall percentage change will be the same. And so that's sort of a very important idea, because it suggests that the starting amount does not change the percent change. In other words, the only thing that is important is the rate. And so we're going to be dealing with a lot of finance problems in this chapter, and I want you to keep that in mind, that the rates are what control the amount of change in an account or any other thing that we're looking at. It's not the amount of money that you start with. That has no bearing whatsoever on the change in the money. The change in the money is due purely to the rate. All right, thank you for watching.